Okay, in this video we're going to look at how to name ionic compounds with polyatomic anions. In our first example we have lead 4 nitrate. Lead 4 is Pb plus 4. Nitrate is NO3 with a -1 charge. And remember that NO3 is a polyatomic anion and it's going to act as a single unit. Whenever these two come together, the charges will crisscross, meaning the -1 will come down here on the lead, just the 1 part, and the 4 will come down and be a subscript for the nitrate. And we look at our final result here, we have Pb1 NO3 parentheses 4. Remember, you have to use parentheses because you want to say you have 4 nitrates. And in chemistry we usually don't write 1, so you don't have to include the 1 after the lead. And so your final answer is Pb parentheses NO3 4. Okay, we can do another example. From the name to the formula with polyatomic anions and ionic compounds, we could have, let me think of one here. Sodium, and sodium's going to pair up with sulfate. Sodium sulfate. Sodium is Na, sulfate is SO4, -2. Sodium always has a charge of +1, so that's why we didn't have any Roman numerals. So we're going to crisscross the charges and come up with our formula here. Sodium has a 1, sulfate has a 2, so whenever we write the formula, we will have Na 2 SO4. And we don't have to write the 1s because we don't write 1s in chemistry. So that's sodium sulfate. Another example, let's do one that's a little harder. Let's do magnesium phosphate. Look up magnesium, it always has the same charge, it's always Mg plus 2. Look up phosphate on your ion sheet, it's always PO4 -3. And again, we're going to crisscross the charges to come up with the formula. Magnesium has the 2, phosphate has the 3. So when we write the formula, we'll have Mg and then 3 from the phosphate, and then we'll have PO4, and then we have 2 from the magnesium. Now you don't want to say Mg3PO42, you want to say Mg3PO42. You want to say 2 phosphates and 3 magnesiums, not a phosphate and an oxygen that you have 42 of. So not 42 oxygen, you have 2 phosphates. So we have to use a parentheses. So Mg3 parentheses PO4 2. Now we can go from the formula to the name. Let's practice that. We have, let me think of one here. Have some iron, we have 2 of him, and then we have PO4 3. So this is very similar to what we've been doing in the earlier video about ionic compounds. This is ionic, it starts with a metal, so we're just going to say iron. We look at what type of metal we have. It's a transition metal, so its charge can vary. And so we're going to look at the subscript on the phosphate, and there's 3 phosphates. So the 3 came from the charge of the iron, so it's iron 3. And I messed up. Let's not use phosphate. Let's use, because phosphate doesn't have a charge of 2. Let's use what's the charge of 2? Sulfate. Iron sulfate. Iron 3. It's a 3 here. Sulfate has a -2 charge always, and we don't have to say that in the name, so we just say iron 3 sulfate. Alright, I messed up on what polyatomic I had in my example. Sorry about that. But it's iron 3 sulfate. The 3 is the subscript on the sulfate, and so you have to specify that it's iron 3, not iron 2. Let's do another example. If we had FeSO4, there is no subscript here, but we know that sulfate Should have put a 2 here because sulfate is always SO4 negative 2. Well, there's no 2 there. We didn't write one. So it's FeSO4. That means that the iron must have had a charge equal to that of the sulfate because we just have a 1-in-1 ratio. So iron must have had a positive 2. So when we go to name, we have iron, and we want to say 2, sulfate. So iron 3 sulfate look like that. Iron 2 sulfate looks like that. Very different chemicals, and it's just because of the charge on the iron is different, so the ratios between the iron and the sulfate will be different. So this was a 1-to-1, this is a 2-to-3. And remember, they're balanced. These ions come together so that the overall charge on the compound is 0. So your sulfate charge has to balance out the iron's charge. So that's where we get this 2 and 3 subscript. And when we go to name it, we have to say we have iron 3 sulfate or iron 2 sulfate. Alright, let's do one more example here. We have Li3PO4. Okay, in this we have lithium. Lithium is always a positive 1, so we just say lithium. We don't have to decide what its charge is. We always know lithium is a positive 1, so we just say lithium. Phosphate is always negative 3, that's why there's a 3 there, but we don't have to say that in the name. We just say lithium and then phosphate. And so type 1 ionic compounds with a polyatomic are very easy because you just say the name of the ions. You just say lithium and then you just say the phosphate. You don't worry about the charge or anything. Okay, that concludes the ionic compounds with polyatomic anions in them.